The purpose of this video is to show the measurement of cone, and we're going to also simulate a sphere in a cone, and we're also going to do a physical by putting a sphere into the cone to do a correlation study. So first of all, I'm going to call the recall button. What it's going to do is the machine is going to rerun the part program. It's going to measure a plane on the face first. Then I go down and I measure a circle or a cylinder. There's a cylinder that goes down at the bottom of the cone. Then we'll come back and I'm going to measure the physical cone. Once I measure the physical cone, I establish an axis through the cone and I level it, which makes the machine measure along the axis of this cone. After we measure this cone, we intersect it with the plane, create a temporary datum, and we look at it in two views. The first time we look in the first view is called the XZ view. We measure a line down this face and this face, and we lay a circle in that view. We also do it in the Y view. We lay a circle in it. After we lay the circle in the two views, then we construct a sphere around that. Next, I'm going to ask to drop in a ball. So I'm going to come over and drop a ball into it and press the OK button. The machine comes down and does a simple measurement on top of the ball. Now I did this measurement of the ball. It wasn't really necessary, but I did it for our correlation. So when we click on the calculation, we can see we got about 90 millionths correlation between the physical measurement over the ball and the constructed with the two circles. But you can see here in the illustration, here's the sphere that's created. The sphere is 625 thousandths. You can also see things like the intersection of this with the tangent plane. And with the tangent plane, this is where the plane hits this cone right here. We can get the depth from the face to that plane. We can also get from the top of the sphere to that seating face. And we can also get the intersection of the cylinder and the cone to the sphere as well. In other words, we can get all the measurements from the cone, from the top, from the center, the bottom of the cone, the seating face, and this concludes this little demo.